Hello, this is Mr. Jared, and in this video lesson, I'm going to be taking you through the dial caliper and measurement basics presentation. So first are just a couple review slides. Hopefully there's a review for you. And I just give you some simple definitions of radius. So radius is the measurement from the center of a circle or arc to the outside. Okay, so if you see this picture, it's from the center to the outside. Diameter, however, is from one side of that circle passing through the center all the way to the other. So in other words, it is twice the radius. And you can see the typical symbols that you see here. Radius is easy, there's just an R. And then diameter, you almost see like a circle with a line all the way through it. I know this is also like the no-say or null-say answer, meaning there's no answer or no solution in other math classes, but this is also the diameter symbol. They do not put a large D or a capital D like they do for the radius. They use this symbol. So again, diameter is from one side of a circle all the way through the exact middle to the other. So it is twice the length of radius. Circumference, however, is all the way around the circle, all the way around the circle. Now, when we're measuring in class, the main measurements that we're going to be talking about are mainly radius and diameter, not so much circumference. But when you are measuring things, you want to measure with accuracy and precision. And there is a difference here. So accuracy is the degree of closeness to the measurement. So you have how close you are to its actual measurement, whereas precision is like your repeatability. So if you measure over and over and over and over, how close are your results? So I have three little examples down here. The first one's like a bullseye, and if you want to hit dead center of this bullseye or this big red circle, here you can see that you are pretty darn close to the middle, like where you want. So if this was in terms of a measurement, and we have 4 different measurements, each one of these little black dots are a measurement, we're close, we're pretty accurate, but as far as precise, we're all over the place. So we might be a little bit high, here or there of the measurement, a little bit low of the measurement, but we're close to the actual measurement. So in this case, you have high accuracy, low precision. On this one, you are not accurate. You're not real close to the actual measurement, but you're getting the same answer pretty much every single time you measure. Okay, so this would be low accuracy and high precision. In this case, this is how we'd want to actually measure, and here you would have high accuracy and high precision. So in other words, when you are measuring, if you are measuring something correctly, you should get the same answer or very similar or very close to the same answer every single time. And obviously, it needs to be the actual measurement that it is. So you don't want to have your caliper for this instance or a ruler or something not measuring correctly. Okay, so there's a video here that explains this entire thing. I don't expect you to actually watch this, but this guy does do a lot of great math videos that explains things like precision and accuracy. Okay, so in our class, we're going to be, so scientists and engineers, and especially in our class, we're going to be using just the significant digits. Okay, normally significant digits, in my case, are just your 3 decimal places. So it's normally numbers that carry meaning. I know in some science classes they call them sig digs, like as an abbreviation. In this case, you can just say your tens, hundreds, thousandths. We're just going to be rounding to the thousandths or measuring to the thousandths. Okay. So we're going to be using a dial caliper, which is actually a precision measurement tool. So it's getting a very, very precise measurement, meaning it is very close to the answer, so it's accurate, and it's also going to give you the same measurement every single time. Okay, the dial calipers we have in class will measure slightly more than 6 inches, but as small as 0.001 of an inch. That's really tiny for a measurement device. And this dial caliper that we have is pretty typical, around this size, the 6-inch mark. Okay, so there are different parts of the dial caliper that I'll just run through really quick. So this is what a full dial caliper would look like. And you have your blade, that's this part right here. I'm a little confused why they call it the blade, because that's actually where your hand grips. And normally your thumb is kind of just right around in here. So I don't typically like to grab blades. So I don't know why they call it that. But this part, the main long middle part, is called the blade. Your slider, this whole entire contraption right here, slides along the blade. And then as you slide it, you actually have this slider tail. This piece right here is actually connected to this. So if you're not careful when you're sliding this back or forth, I have actually seen people hit each other with this or poke each other in the face with it on accident. You got to be mindful of where this tail's coming out at. But that's normally used to measure things with depth, like a hole. Then you have your rack. So your rack is the rack of numbers. Okay, it's like almost like the old abacus. You have a whole listing of numbers on a rack. So that's what you have here, a rack of numbers. You have your slide locker. So if you don't want this slider to actually move, you can lock it in place. When you're taking a measurement and then pulling it off of the object to actually read that measurement, and maybe you set your caliper down, type something on the computer, and then you come back to it, it's helpful to actually lock the slider so that you don't move that measurement. And you just simply do it by twisting the little knob up on top. Then we have our internal and external jaws. Okay, so these little pinchers here and these pinchers here, these are actually external, even though it looks like you'd be pinching something on the inside. That's because the jaws go on the outside of the object, and the internal jaws open opposite of one another, so they slide opposite away. And this is for measuring the inside of something like the hole. So those are your internal jaws. And believe it or not, the dial caliper is actually made correctly so that from here, this edge, to this edge is actually the exact same measurement as it is from this to this, which I know just by looking at this picture or looking at it in person. They're a little bit of an optical illusion because the metal is offset and pointing different ways. It does not look like it's the same, but it is. Okay. Now, all dial calipers have a different reference edge, but normally you are looking right around in here wherever it crosses the rack. The reference edge is larger increments. Okay, these are your larger increments, and then it breaks it down slower. So you just need to find this reference edge and find how your dial caliper looks, because it's probably not identical to this picture. Okay, as an example, you see on this one, there's a little space here. This one is just a straight flat edge. Okay, and I think the ones we have in class look like this. Then you have your pointer. So your pointer is just like on a clock. Okay, it rotates within the dial. The dial itself is this. And of course, you have a dial lock that you can actually lock so that this doesn't rotate around. Why you would ever want to not have this locked, maybe it's when you're recalibrating it or you're trying to measure something and then tear it, just like you would tear a scale, so that you can offset the measurement. Okay, so here are very, very important steps. Every single time you pick up dial caliper, you don't want to trust the people before you. Okay, so you want to re-zero the caliper. Okay, so first you close the caliper completely. You loosen the dial lock, and as you can see here, they loosen the dial lock that's underneath. Okay, then you are going to rotate the dial so it reads 0. So you're going to rotate the thing so it says 0. I have seen these pointers actually going on an angle from people dropping them over time. If you put it at 0, it should be fine. Okay, then you're going to tighten the dial lock. Now, if you do that, it should open and close back to 0 every single time. Okay, now there's 4 different measurement techniques: outside, inside, step, and feature depth. Okay, so the first one we're going to do is the outside measurement. This is the main thing that you'll probably use. This is just measuring between the outside or external jaws here. And the example would be pinching something to find its thickness. Okay, so as an example like this, you'd be pinching it here and here. That's the typical measurement most people use. Okay, then you have your inside. So that's the opposite jaws here. That's the internal jaws. That's these ones that open opposite of one another. And they are measuring between faces, okay, like a slot width or a hole. So as an example, you can actually put these inside of a hole and then open it up, and it will go from one wall to the opposite wall. That'll give you its diameter. Then we have our step. This is one that a lot of students do not know how to use. I was not actually even taught this in college, and it probably would have been very helpful to know in college. because I can now think of a lot of instances where this would have been useful, especially if I would have been scribing something with this little pointed piece here. So measurement between caliper faces, again, an example is like between two parallel surfaces. So you will actually flip it upside down here, and this part of your dial caliper will be flat. And on the back side, this back jaw here actually has a flat piece. So the distance from there to there is going to be your measurement. Now, could you just kind of line this up here and guess? Yeah, you could. You might get close, but this is way more accurate. Okay, and you're going to get a more precise answer, meaning you can measure this 10 times over, you're going to get probably the same answer. Whereas if you just kind of eyeballed or lined your internal jaws or your external jaws up against these two edges, probably not going to get the same measurement. Okay? And then there's feature depth. So if you have a tiny hole or a recess, something that goes down in, you can stick that tail down in there and use the end of this dial caliper to get that measurement, as you can see in this picture. So the tail goes all the way down, and then you slide your dial caliper down until it hits this little flat edge. And when it hits that, that measurement is actually the exact same measurement as the distance here, or the distance from this jaw to this jaw, or believe it or not, the distance from there to the backside jaw, because that would be your step measurement. So there's 4 different ways you can measure with a dial caliper. Okay, so let's do some practice readings, and I'll show you a couple examples of why I put them on here. So first off, let's learn how to read it. It says the rack scale is divided into increments of inch 10. This is rather confusing for most people because, you know, we don't think about measuring into decimals. We go into fractions, and then you have to convert over. But this is actually measuring right into inch 10. So it's breaking an inch down into 10, okay, which in this case gives us easy decimals to read. So each increment equals 1/100,000th of an inch. Okay, so the dial is divided up 100 times, as you can see. Therefore, the graduation equals 1/1000th of an inch. So 1 revolution of the pointer, meaning it goes all the way around, within the dial represents 1/10 of an inch. Okay. So steps for reading the caliper. Again, you're going to zero it. Okay. Following those steps I gave you earlier, you're going to use the correct type of measurement technique, whatever one gives you the best answer, the most accurate and precise answer. You're going to measure that object with that measurement technique. You're going to use the slide locker, that's this up top, and then you can actually look at the reference edge and go ahead and measure from there. So first off, you look right at the reference edge. Okay, so by looking at this in this example picture here, I just copied and pasted it a bunch of times, you'll see a bigger number, and that bigger number will show you how many inches it is. So in this case, it's not past 1. So you see how we have 0, and then over here is like 3 inches, okay? It's not past 1, so we'd have 0 inches, so 0 point, then read the 10-digit increment on the rack. So here it's 7, so 0.7. So rack first, then dial, okay? So then look at the point and read the dial, and here we have 37. So our entire answer is 0.737. All right, so rack gives you these first 2 digits, and then the pointer and the dial give you the last 2. Okay, so now there's some examples. So I want you to maybe pause for a second, pause the video, whatever you need to, look at this and think about what the answer may be. Okay, so once you've kind of figured this out, what you want to look close at is your rack and see where your inch marks are. So there's 0. Here's 1, so it's past 1. You don't see 2 on this rack, so we know the first digit is going to be 1 inch, so 1 point. Now my reference edge is here, so I'm looking at 5, but I really want to make sure that this pointer is past 0. If it's before 0, even though this looks like 5, it's not actually 5. So it is past 0, so we have 1.501. 1.501. Okay, another example here. So maybe pause the video. All right, now, again, let's look at our rack. We have 0 inches, so 0 point. Look at your reference edge. Just by the naked eye, that looks like 1, but if you look over here, this is not past 0 yet. So typically, the answer that most students would say that are wrong would be 0.195, but that's wrong. It's actually 0.095. And you can think about this about looking at, an analog clock, looking at one of the older clocks, not a digital clock, one with a pointer. It might look like, it's 1 o'clock here, but until that goes past the 12 on a normal clock or 0 on this dial, it's not actually 1. Okay, so here we have 0.095. That one's confusing, but there's a reason I put it on this presentation. So if you do need any more help, you can click on the link that's in the presentation. And there's even like a little test there that's, I believe, takes you to Wisconsin University, their engineering program where they teach the dial caliper. But hopefully you learned how to read the dial caliper and you reviewed some math